make a reference to the line. Okay. In nature world, the string is continuous. Okay, but remember in computer science, we always need to make it discrete. Okay, so we have to divide it into a segment, many segments. Then we can define the structural behavior of every single segment. So here I think we can use this curve divide to make a series of points. Okay, and then we are going to use this series of points to create segments. Okay, so if we use this text panel to show it, you see the list of points. Okay, and for every segment, we need to connect the first point to the second point, and then the second point to the third point, and so on. So what we need to do is to shift the list. Okay, so we go to set shift list. And I open another text panel. Okay, we can do the same thing in many different ways, and this is only one of it. Okay, but I think in the case we are going to do, this might be the better way. So we can compare the coordinate system so you know how it is shifted. The first point, 1090, okay, it shifted backward. Now it is at the last. Okay, and the second point with the index 1 become the first point with index 0. So which means if we connect these two lists, then we get all the segments, right? So we go to curve and then connect. Okay, so we get a list of lines. Okay, everything is fine until you see this. The last line, the length is 20. Why? They should be all equal lengths, right? Anyone can tell me why this happened?
Wrap.
Sorry?
Wrap.
Yeah, okay, very good. Because if we show both points, list of points, we connect, oh sorry, here, this one. We connect both lines. We connect this point to this point, right? So we get the first line. And then we connect this point to this point and get this line. But what happened to the last one? We connect this point to this point. But this point is indeed the starting point of the entire line. And this point is the last point. So the last line, it's the line itself, simply reverse the direction. And this is not wanted, okay? And what we have to do is we need to check the behavior of this list. Okay, here there's a rep, and the default value is true, which means when this component trying to shift the entire list, it simply shifts all the points backward for one position. So the second point becomes the first point, the third point becomes the second point. But what happened to the first point? Because it is wrapped, so it's like a necklace. Okay, it is circular. So the first point shifted backward to the last point. Okay, but if you turn it to false, set Boolean false, you see the last point disappear. Okay, it was the first point, and when the rep is set to false and then you ship it backward, then it is shifted out of this list. Okay? But what happened if we set it to false? Now you get this line, this is zero length line. Why? Because this component is trying to match all the input in both input nodes. Okay? For I think maybe I should reverse them. Okay? This is the first one and this is the second one. Okay? So it tried to match each input in the first point list to the second list of points, one-to-one mapping. Okay, so this point leads to this point until it reaches the end of the second list. And then the last point for the first list finds no match. And what happened? It just simply assumes that you reuse the last one. So the last point, the last line is the connection between this point and this point, and they have identical coordinates. So that's the reason why this line is 0. Okay. So what you can do is we use this set shortest list, and then you send the first list to here to A and the second list to B. So it will trim the end here, trim the end of the longer list, and then make both lists have the same length. Okay, and after you do this, then you get this one. Okay, and now here we have this straight line, right? But what happens if we have a closed lamina? What happens if we have this one? Okay, let me make a reference. If it is this one, then if you take a look, the lines that we create, these green lines, we see these green lines, there is one missing. Okay? Because the last one, simply you need to connect the last point to the first point. So with this rep set to false, you are not going to create this. So in this case, you need to set it to true. And when you do that, then you have the complete segmentation of the curve. Okay? And you can check it. Yeah, it is fine for everyone. Okay? So what can we do to deal with both situations? In one case, we need to set the rep false. In the other case, we need to set the rep true. Okay, how can we distinguish these two different situations? Okay, any suggestion?
Close line,
Sorry?
close shapes, or not?
Yeah, sometimes we want to simulate the open curve, and sometimes we want to simulate the closed curve. So how can we write a program that is capable of dealing with both situations? So we need to analyze the curve, right? And in one situation, we set the rep as true. In the other situation, we set the rep as false. So in what kind of situation, and how can we distinguish these two different types of situations? What we have to do, we need to check some property of the curve, right? What kind of property?
Close or not?
Yeah, close or not. Okay? And when you think of this, then we can try to find, I mean, maybe you don't know what you can do for this, but then you have this objective, then you know what maybe it can be found, right? So, because it is regarding curve, So of course we go to curve category. And then curve category, there are many groups. And you see the first group is called analysis. So we want to analyze the curve to see if it is closed or not. Okay, so we open it, and yeah, very luckily we find this closed. Okay, so we can use this component to analyze the curve. And when it is closed, then it shows you true. Okay, so we simply connect this one to red. So when it is closed, then the red will be true. When it is open, then the red is false. Okay, so with this, we are able to segment the curve, open curve, closed curve, or open curve, okay, to the segmentation that we want. Okay, so now we want to simulate this curve as a physical structure. I mean, not only showing it on the computer, but we want to simulate the structural behavior of it. Okay, so we go to Kangaroo 2. First, we have to keep the length of all these segments, right? So this is the first thing that we can do. So we go to Kangaroo 2, and there is a group of components. For that, we can set the behavior of regarding line segments. So here, I think this time we have been using it. So we set the length of line. If you don't have any input for length, then it will, by default, it will try to maintain the original length of it. And also you have the default strength as 10. Okay? So if we have only this, then what kind of behavior we are going to get? So before connecting this to the Kangaroo, like last time, we make a end line.
Teacher,
Yeah.
can you please include bifocal?
Oh, sorry. Yeah. Bifocal. Okay.
Thank you.
Yeah, you're welcome. Ny. Okay. Connect to it, and then connect to the goal objects of the Kangaroo. And you need the switch so that we can turn it off. We also need the button so that we can reset it. Okay, but now we can start the simulation, but we cannot do anything on it. Okay, we cannot check what kind of behavior. So maybe we like to grab it using our mouth. So we add this grabbing here as one of the force object. So now we can simulate it and try to see if you can grab it. Okay, so now we can grab. Okay, but this is not the kind of behavior that we want to simulate, right? So we need more forces. Any suggestions? Any suggestions? What kind of constraints we can assign to this segment so that it can better simulate like a string, maybe not, I shouldn't say string, like a elastic stick. Okay, so you can bend it and then it become a curve. Do I have that somewhere here? No. Oh. Yeah, like this, right? So when I hold it upright, it won't fall down because it has a structure. And when you hold both ends, it starts to bend. And then, because there is a weak point, but if there is But if the structure is very smooth, then it becomes a curve when you try to bend it. Okay, and with a single string, we are not able to simulate twisting. But when you make it some certain width, and then you define the proper structure behavior, then we can start to twist it. Okay, any suggestion? What kind of force object we can add so that the behavior of this green thing will act more like the physical structure of any suggestions? Okay. If we try to maintain the angle between each line segment with its neighbors, right? Maybe it acts more like the thing that we want to simulate. Okay, because whenever you pull this node, it simply moves, okay, without any resistance to the place where you drag it. And then the angle between this segment and this segment simply change, okay, depending on how you pull it. Okay, so if we add some kind of resisting force to try to maintain the initial angle between all these consecutive line segment, okay, then we can see what kind of behavior of it. So now we need to add another force object, goal object, and it is regarding lines. Yeah, but okay, sorry, in lines we don't find it. In angles, we want to maintain the angle, so you use this angle. And if you check the input, you need to input two lines. And in our case, you need to find the line and the next line segment of it. So we can do the same thing, right? Now here we have a list of lines. And then we have to use, oh sorry, the lines are here, okay? So we have to connect this line with this line and then maintain the angle. Okay, so we have to do the same thing, right? Using this one and this one. We copy these two components and this time use it for lines. Okay, let me add more spaces. You press Ctrl key and then you drag your mouse, then you can create space out of nothing when it is too crowded. Okay, understand this? I want to get every line segment and then combine it with the line segment which is next to it. So I make a shift so that the position of all lines in this list is shifted backwards. Okay, and then the original list and the shifted list, and then when it is not wrapped, then the shifted list will be one shorter than the original list. So we need this shorter list. But when the curve is closed, here we have analyzed the curve. If it is closed, then this wrap will be true. In that case, the number of lines in this list and the original list are the same. So actually, in that case, this shortest list doesn't do anything. Okay, but it is fine because when the curve is open, then we need this shortest list. So after we have done this, then we connect this A to the line A, B to the line B. Now we have another set of force object, and then we can add it to the simulation. Okay, and every time you make any change, you always need to reset it. Okay, now we see the behavior of it. Okay, right? So now the curve will try to maintain the angle of all the line segments. So it behaves differently. Okay, and maybe not much we can do with this because right now the structure flow in the empty space. Okay, so you can drag it, but it always maintain the same structure. Okay, so if we somehow try to anchor some points, then we can see the difference. So we go to this list of points, and we try to anchor the first and the second points of it. So we go to set list item. Okay, let me check. Okay, I have to stop